Hi guys, this equation today is going to cover two things, factored form and vertex form. We're going to start off with the factored form. This is the basic form for factored form, and yes, you ought to memorize this so that you understand all the components of it. One thing to notice is there is a minus sign, and that minus sign means that things are going to be a little bit different in their signs, and we'll kind of talk about that along the way. But just make sure that you notice that as a minus sign there. Why is it called factored form? Well, you probably remember from your old math classes that when we have a quadratic, we can factor that quadratic. So this is called factored form because it is factored, which seems really basic, but that is why it's called factored form. However, another name for this is called intercept form. Some textbooks call it intercept form. And the reason why they would call it that is it shows us what the intercepts are. It's really easy from this form to find the intercepts. And so that's why we're going to work in the next couple of weeks on factoring a lot, because that's what helps us to find intercepts. And so factoring is a huge part of algebra. Now, each form that we learn has different benefits and different things that it gives easily and what have you, and different rules for things like how to find the axis of symmetry. And so the axis of symmetry that we are going to use from factored form is we're going to take our P and our Q and we're going to average them. And so we're going to take P plus Q and divide by 2, and that's going to give us our axis of symmetry. Notice it is the positive P and the positive Q. All right, so just keep that in mind as we go through here. But that's going to be the axis of symmetry. With standard form, it was negative b over 2a. And this time, it's p plus q over 2. How do we find the vertex then? Well, same thing as with standard form. With standard form, we would take whatever we got from the negative b over 2a, we would plug it in, and we would find y. Same thing here. We're going to find the axis of symmetry. Whatever we get for that x, we're going to plug that x into the function and solve it to find y. And finding the y-intercept. Finding the y-intercept always is plug in 0 for x and solve for y. That's how we always find it. And so anytime you want to find out one of the variables, you plug in 0 for the other variable and it will give you that variable. So that's how we're going to find the y-intercept. On this graph, the way it works out, we're going to get some pretty big numbers. And so we're going to count by 3s on our y-axis. Our x-axis, we're going to continue to count by 1s. And I don't usually like to do that, counting by different things on the x and the y, but this one just comes out to where the numbers are so big, that's really the only thing that's going to make sense for us. Okay, we have to fill in all this information just like we were doing for standard form. So we look and we see that it is negative, that means it opens down. And if it opens down, that means it has a max. Okay, let's take a second to find the vertex on this one. The vertex is x equals p plus q over 2. In this case, our p is 4 and our q is negative 2. Okay, because we had to switch the sign because of that minus sign in the original equation. And so this is 4 plus negative 2 over 2. That's 2 over 2. That is 1. So the axis of symmetry is x equals 1. For the vertex, we do just like we did with the other one. We're going to take that 1 and we're going to plug it into the original equation and solve it to find our y value. Okay, so we come out to be 27, and that is why we had to count by 3s, because we have to get up high enough to get to a 27, because our vertex is going to be 127. And so that means our min or max value, which in this case is a max, is 27. Remember, for our y-intercept, we plug in all of the zeros for the x's this time. And so we're going to get y equals, and we have a negative 3 times a negative 4 times a positive 2. And so our y-intercept is 0, 24. Again, a pretty high number, which is why we're counting by 3s. Okay, our domain is always negative infinity to positive infinity. Our range, before we do range, let's go ahead and graph what we have. So we have an axis at 1. We have a vertex at 127. So we're going to count by 3s. So our vertex is at 0, 27. Our y-intercept is at 0, 24. And so it's going to open down like this. Now let's think about how this is going. We went down 3, right 1, or left 1 in this case. So if we take our 1, 3, 5 pattern and we multiply that by -3, it's going to go down 3, which we did, and then down 9, which on our graph paper is actually 3 boxes. And then we'll have the reflection over here. And then we're going to go down 5, etc., etc. So our parabola is going to look something like this, keeping in mind that our y's are counting by 3s. So although it looks like this, it actually is stretched out and taller by a factor of 3 than what it looks like because we counted by 3s. But we had to fit it on the graph, so that's what we did. Okay, let's get back to our text box. Our range goes from -infinity all the way up to 27. We can see that we will have 2 real solutions. Now, what are those solutions? I'm not sure if we can find out what they are from this graph. Let's double check and see. So we went down 3, we went down 9, which was 3 boxes. We're going to go down 15. Well, it looks like we will see what they are. So I didn't draw mine very well because my parabola should be crossing there at -2, 0. And because of the symmetry, that's going to cross here at 4. So it was -2 on the left-hand side and 4 on the right-hand side. Where is it increasing? From -infinity to 1. And decreasing from 1 to -infinity. Remember, those are the x values that we're talking about there. And our end behavior, it's going to go towards -infinity on both sides. And so the way we write that, as x approaches -infinity, f of x approaches -infinity. And as x approaches positive infinity, then f of x approaches -infinity. That is, both sides, the left side and the right side, are both going down. Okay, as we look at number 2, it looks a little bit different. It looks like maybe it's not really in factored form, but actually it is, because what does a square mean? That means multiplied times itself, right? And so what we really have is this equation, which is the same thing as that, but I can just rewrite it this way so that I understand what it means. Now, we know that this opens down. Take a minute to fill in as much as you can, and maybe you don't know all of it because of that double factor, but fill in a little bit and then I'll come back and help you with the rest of it. Actually, let's go ahead and pick up for the axis of symmetry because, again, it repeats, it's the same, but that just means that our axis of symmetry is going to be a -3 and a -3, and we're averaging that. Well, the average of -3 and -3 is -3. So our axis of symmetry is at x equals -3. I'm going to take a second to graph that. Now, to find the vertex, we take that value, that -3, and we plug it into the function. And as it turns out, -3 plus 3 is 0. So 0 squared is also 0. So our vertex is at -3, 0. So it's at -3, 0. It opens down. So it's going to look like this. And I'm just going to count my 1, 3, 5 pattern, going down 1, going down 3, going down 5. And so this is what my parabola looks like. It's a little bit different than some of them that we've done because its vertex is the x-intercept. So the max value is 0. We'll get to the y-intercept in a little bit, but let's talk about the domain and range. That means that our range goes from -infinity all the way up to 0. And of course, we need to make sure that we include that 0 in our range. And of course, our domain goes from -infinity all the way up to positive infinity, to the left and right. How many solutions do we have? In this case, we only have one solution, and that is the x-intercept. So the x-intercept is -3, 0, which is also the only one. So when we write it like this in the original problem, if you look up at the original problem, it has this square on it. That just means that you're going to have it there, but it's the only one. It's repeated. If we wrote it out the long way, it would be repeated, but really it's just the only one. And so where it's increasing from -infinity all the way over to -3, those are our x values, decreasing -3 to infinity. And behavior. As x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, f of x also approaches negative infinity. That just means on both sides, they're both going towards negative infinity. Okay, before we turn the page, if you have questions about factored form, write them down in the margins, write all questions in the margins, and bring them to class tomorrow. Okay, let's turn the page. Okay, the last form that we're going to talk about is vertex form. Once again, notice the minus sign. There is a minus in there. Why is it called vertex form? Because it's really easy to find the vertex. In fact, what is the vertex? It's just HK. That is your vertex. How do you find the axis of symmetry? Super easy. X equals h, and that's it. How do you find the y-intercept? You plug in 0 for x and you solve for y. That's always how we find the y-intercept every single time. Doesn't matter what the form is, we always do that. So let's go ahead and look at some examples. The main thing here with this, again, like I said, there is a minus sign inside the parentheses, and so our vertex is just 1, -5. Basically, anytime it's inside parentheses, it's going to be the opposite sign. If it's outside the parentheses, it will be the same sign. And so if that is our vertex, that means that our axis of symmetry goes through the line x equals 1. Obviously, this opens down, and if it opens down, that means there is a max point. Let's take a second to graph what we have. Okay, now that we've graphed what we have, we can very easily see the rest of the information. So our max value is -5. The y-intercept is -7. I can see that by graphing, but I also could get that by plugging in. In fact, let's go ahead and take a second to plug that in to see how to do it. It's the same as we've always been doing those. We're going to plug in a 0 for x. Okay, so when we plug in a 0 for x, we get 2 times 1 minus 5, -2 times 1 minus 5, which is 0, -7. Which means that our domain is always negative infinity to positive infinity. Our range goes from negative infinity all the way up to -5. There are no solutions or x-intercepts. Okay, where is it increasing and decreasing? From negative infinity all the way over to 1, x values. Decreasing from 1 to negative infinity. The end behavior, they both go towards negative infinity. Okay, once again, questions, write down your questions in the margin. If we look at number 2, we need to make it look like vertex form. It doesn't really look like vertex form right now, but we can make it look like vertex form. Kind of one of the characteristics of vertex form is it has this x something squared inside the parentheses. Well, we can just use a 0. We can say it's x minus 0 squared, and then we have it in vertex form. Okay, now that it's in vertex form, go ahead and see what you can do with filling in the text box and filling in your graph. Pause it here and try to see what you can get. Okay, one thing as I was looking over number 2, I realized I made a mistake on number 1. And my mistake was on the range, that ought to be a square bracket because it does include the point -5, so we need a square bracket there. But going back to number 2, opens up, has a minimum, vertex is 0, -2, axis x equals 0. Max value, in this case the min value, is -2. Y-intercept is also 0, -2. So we have the vertex and the y-intercept being the same thing this time. Last time, or a couple times ago, we had the x-intercept, but this time it's the y-intercept is also the vertex. Okay, the domain is negative infinity, positive infinity. The range goes from -2 all the way up, and it does include -2. There are 2 solutions. Now, we have not discussed how to find them yet. That's one thing that we're going to work on in the next section. So we will learn that eventually, but right now we don't know how to do that yet. It is increasing from 0 to infinity. That is, from 0 to infinity, it's going up. And from negative infinity to 0, these are the x values, it's going down. The end behavior, both sides are going towards positive infinity. Okay, once again, if you have questions, write your questions in the margins. I don't have a place for summary here. I feel like a lot of this maybe is already explained because of the top. We kind of have a summary at the top. But anyway, if you want to write a summary, you can, but I'm not going to count you off for not writing a summary. This basically up here, this, we can talk about this as our summary. Okay, any other questions? Write them in margins and bring them to class tomorrow.